Alright, I'm going to do a video with the first and last problems. There's something a little different about each of those, so. Alright, but in general they're the same problem. So, solving equations, you'll first find the LCD. Okay, to find LCD, just look at just the denominators for now. Alright, and then you look at all the numbers. So here the numbers are just, you have a 6 and a 3. And you want to find the least common multiple between those. The smallest number that these divide into. So they both divide into 6. 6 is the least common multiple. Okay, so 6 will be a part of the LCD. And then you look at all the variable parts. So you have a k squared, and a k squared. And keep in mind, this is like a k to the 1. Okay, so you have these three terms that all have the same base, all k, k to some exponent. And so the LCD just gets the biggest exponent. So k squared, that'll be part of the LCD. Okay, so we'll write that. Okay, so that's the LCD. Okay, so now we're going to take that LCD and multiply it by each term. So this term, and this term. Just each thing that's added or subtracted on either side. Okay, so we'll take the first term, multiply that by the LCD. Okay, the term on the right. Times that by the LCD. Last term multiplied by the LCD. Okay, now you and just kind of look real quick. So you have, see how this term here, exact same thing, just multiplied by the LCD, right? Equals, right? You're just kind of carrying everything over, but just just kind of giving yourself enough room to multiply it by the LCD. All right, you don't got that. I don't know why I said that. All right. Then you cancel. Okay, so those cancel out completely since they're the exact same thing. The next set, the k squareds cancel. And then the 6 and the 3, you can both divide by 3. So 6 divided by 3, whoops, is 2. 3 divided by 3 is 1. Okay, and then the last set, the k squared and the k will cancel. But since, this is a k squared, so there's like 2 k's on the top and just 1 in the bottom. So that k will cancel out with just one of those k's, and you'll have a k left on top. Alright, so now you're just going to rewrite everything that's left, just multiply together in each kind of set of, each of the 3 sets of terms multiplied by the LCD. Alright, so the first thing left, the only thing left here is a 1. And then, carry over that equal sign. Okay, next thing, only thing left in the next one is a 1. Oops. Is 1 times 2. It's 2. And then minus, carry over that minus. And then the only thing left is a 1, a 6, and a k. So 1 times 6 times k is 6k. All right, and then that's always kind of the toughest part. You got to be careful of a couple things. So now just start solving for the variable. You can do different ways. I'll minus 2 from both sides. Okay, 1 minus 2 is negative 1. That's negative 6k. and then we'll divide by -6. Get rid of that. Okay, and then anytime you have just kind of two negatives somewhere in a fraction, those will cancel out to be a positive. So k is 1/6. Okay, for this next one, we're going to find the LCD first, just like we did last one. And I should have said with the other one that you should look to factor, but in the first problem, no denominators could be factored since there was no addition or subtraction. You can only factor when there's some addition or subtraction. Okay, so first we'll I might just rewrite these with the denominators factored, but you can do stuff like cross out the denominators and factor them, whatever. Okay, so the first fraction, top is p plus 5, and then this bottom, you see this has an LCD, or yeah, wait, what am I saying? Oh, greatest common factor, sorry, GCF, of p, so you can pull out a p from there, and then you'd be left with p plus 1. Okay, that's the same thing for the next one. Okay, and then the last denominator, p plus 1, you can't factor, so it just stays. Okay, so now we can find the LCD. So look at all the different factors. There's a p here and a p here, so that's a factor, and that'll go in the LCD. Okay, and then you have a p plus 1, a p plus 1, and p plus 1, but none of them have an exponent to them, so that's just p plus 1 goes in the LCD. Okay, so even though there's like 3 p plus 1s, there's only one, the most in any single denominator is just p plus 1. There's no p plus 1 squared. Sometimes these could have exponents. All right, anyways, okay, so now we'll do the same thing we did last time. Take each fraction and multiply it by the LCD. Okay, and keep in mind the whole reason that we're doing this, and there's other ways to do this, but the whole reason why I think that this is a good way is because it gets rid of the fractions. That's kind of the whole point. So after we cancel, there should be no fractions, and it's just kind of nice to deal with equations that don't have fractions, I think. So now we cancel. So that whole thing cancels out with that whole thing. So we just have a p plus 5 left. The first. Same thing here. So just a 1 left. And then the last one, the only thing that cancels is the p plus 1s. So there'll still be this p left. Okay, so things to be careful of is how to kind of deal with this p minus 6, and then this negative, especially this negative here. So you got to be careful like how to deal with that. So I'll show you how that goes once we come to that. Okay, so just like we said, so we'll just rewrite that. There's nothing to multiply by it, so just that's it. Same thing, next one, just a 1 left. Okay, so then this is how I would do this. I would just do, this, rewrite this minus sign just as we're going. And then really we're multiplying p and p minus 6. So kind of always a good idea if you're not sure is like put that in parentheses. Like it never hurts to put something in parentheses, unless you kind of do it in a wrong way, I guess. But anyways, I don't know. All right. And then we'll just rewrite minus, and I'm going to write this p first instead of, these two things are multiplied. You can write either one first. I'll write it first because it's like what we're used to. Whoops. Okay. Now the reason why I wanted to do this one is this one ends up being a little different the way that we solve. Okay, so this looks the same as the other ones, no fractions left, just variables and numbers. So let's start simplifying it and we'll see why this one's a little different. Okay, so we always have to get rid of parentheses in these. So we have like this minus p that'll distribute to each of these. So it's like minus p times p minus p squared. And then minus p times minus 6. Negative times a negative is a positive. So it's a positive 6p. All right, now the reason why this one's different is because we have this term. This term here has an exponent, has a squared. And anytime you have an equation where the variable has an exponent, you're going to solve it by getting everything on one side to get it equal to 0, and then factor. Okay, so we're going to get everything on one side. So I'm going to bring everything over to the left. So like I'm going to add p squared to both sides. I'll kind of line things up a little way. Okay, so those will cancel. And then minus 6p from both sides. Remember, kind of line it up with the like terms. These are like terms, so we'll line them up as we go. And those cancel. Okay, and then a minus 1. And notice these are with like terms. And then those cancel. So notice everything canceled on the right. And if you want to do this in more than one step, it doesn't matter. Okay, so we have p squared. Oops. Okay, p minus 6p is negative 5p. And then 5 minus 1 is 4. And since nothing's on the right-hand side, that equals 0. Okay, now we factor. So this is a normal method. So think about what two numbers multiply to be positive 4 and add up to be negative 5. That's negative 1 and negative 4. Okay, and then, technically we're setting that factor, p minus 1, set that equal to 0. The other factor, p minus 4, set that equal to 0. And then we're solving each one of these. Okay, but remember, it's always just the opposite. So like this is p equals 1, because it's like the opposite of that. That's why the next one, the answer is going to be p equals 4, since that's opposite of negative 4. Okay, and then this has two answers to it. So some of them have more than one answer. And that's what this one does.